Hi everyone, my name is Yunzhi. I'm a data analyst at Meta. So today I'm going to talk about map data improvements with emerging technology. 8 years ago, this topic actually can be controversial because the limitations of technology oftentimes cause community members raise concerns about the quality and accuracy of data generated from all these emerging technologies. However, this emerging technology is a key step to scale up the data generation and data quality assessment. So over the last 8 years, Meta actually has been exploring this domain a lot to trying to tackle different challenges with the emerging technology. So back in 2017, if anyone already involved in OpenStreetMaps, you may remember this. So Meta developed these machine learning models to predict raw data directly from a high-resolution aerial image. And we later refine our post-processing steps to get the better results. And we also built a tool called Rapids to allow us to host this machine learning data in the tool and share to publics to have easy access to all this machine learning data. So they can use for their use cases. And also in 2019, we developed a machine learning models. It's a customized machine learning models for detecting vandalized names as part of the daylight map building process. And then during pandemic, we started zooming in our focus on footway data. And we find that processing the connectivities is challenging. So we started develop these graph-based row conflation methods to preserve connectivities. So these new methods introduce some new ways to process graph constructions, point mergings, and edge mergings, especially for multi-source data sets. And then in 2023, because we want to get involved into the high-fidelity maps, so we start exploring technologies to how to build high-fidelity maps. We use the USGS LiDAR data and combine with the overture building footprints to derive building height of each building. With those results actually have relatively high accuracies. And we share this through overture maps. And then in the last 2 years, we shift our focus back to pedestrian data. So we start working on some machine learning models to predict sidewalks and crosswalks, so we can easily fill the gaps of pedestrian data in different cities. And this model is not just limited to air image anymore. The model has been developed both on the air image and street level image. And these are some results that we have. We have more details in my presentations back in Mapping USA this year, if you're interested. Actually, each of these historic efforts that we have made that attach the presentations in these slides. So what do we do recently? So this year, we face another challenge, like the resource challenge start kicking in. So that's why we start thinking about, can we use Gen AI to help us to prioritize our efforts, to optimize the usage of our resources? So we have done a lot of different experiments trying to using Gen AI, and I'm going to share 2 examples here that how we experiment Gen AI on helping the map improvement. So the first example I'm going to share is using Gen AI to find focus area. So with limited human resources, to map the entire countries, even with machine learning data, it's kind of not feasible anymore. So we start thinking about, okay, we want to have a lot of pedestrian data being available on the maps. However, there must be some area that are popular and people are most likely to walk around that we can prioritize. So we use the Gen AI to help us we build models using LLMs to help us to find out these focus areas that we can prioritize our human efforts. And here's the prompt engineer journey. So we start by giving LMs a list of city names and ask LM to generate interesting areas for us in each cities. But the results is not very good because the LM result often suggests the residential neighborhood with no POI. So we add a constraint to LMs to ask them not just focus on residential neighborhoods. It actually mitigates the issues. And for all this interesting area, we also want to have the double KTs, the valid polygon in double KT format. So we ask LM to generate the double KT polygons. But again, the initial result was not that good. So we started thinking about what other things we can try to improve it. So we give LM the central input of the cities, and then ask LM to generate a centroid of each polygon of the interesting area, in addition to the polygons. And then we also ask LM to generate slightly overfitting polygons. So at the end, we actually got relatively decent results based on all the combination of the constraint that we sent to LM. So we later want to get more improvements of the interesting area. So we rank the area and then ask LM to rank the area and provide the descriptions. Surprisingly, with these requests, LM actually have a way better results of interesting area of each cities. And we want to do more on that. So we test different temperature of LM, and then find out increasing the temperature of LMs give us even better list with creative descriptions of each interesting area without sacrificing the polygon quality. When we're getting closer to the final stage, we notice there's some city confusions. For example, French Quarter in New Orleans somehow is miscategorized as an area in Houston, Texas. So we provide LM the central of the city geometry again to try to improve the results. And it did fix these city confusions after it. So the model performed the best in a larger size city or medium sized cities, but it does struggle in small cities. These are some example results in New York and Boston area. And this is the other examples in a small area, a small town called Grand Fork. We also have a collaboration with youth mappers. So we use the LM results for interesting area and combine with other metrics to redefine where to map to optimize the limited hours of these youth mapper groups and better use their time to help mapping the interesting or highly focused areas of each cities. Another example I want to talk about is the LLM on name validations. As I mentioned earlier, we have developed a customized machine learning models to detect vandalized names. So as our collaborations with Overture evolve, we decided to transition daylight validation to Overture ecosystems. But our machine learning models actually is not very easy to transitions because all the computation limitations and a lot of other blockers. So we start exploring different methods, which is LM, to see if it can help to detect vandalized names. So what we do is we also pull in candidate names from OSMs, and we ask LMs to give us inference of the candidate names and categorize them into the 7 classes listed here. And we take the high priority classes, which is the one that highlighted in red, and to a storage space in Overture called violation stores, and push this result to map relays for manual review. So far the results actually looking pretty accurate. These are some example results. So this is the journey so far that we have working with emerging technologies. Honestly, the Maps team at Meta is a really small team, and using all this technology did help us to tackle different challenge very efficiently. But when we are very excited with our success and achievements, we always step back a little bit to think about these questions. As Gen AI and other technology continue to advance, will manual effort eventually become obsolete? I personally think the answer is no, now, because in fact, think about each development that we made, we involve significant amount of manual efforts to validate our technologies. But another 8 years, if I still have the same answer, I don't know. But I think this is a question that is worth to keep thinking about whenever we developing the technology and trying to advance our technology. So this is my talk. So at the end, I do want to mention that we are hiring. There's 2 roles. One is a project manager that will be US-based, and there's a customer success manager, which is a UK-based. And if you're interested to apply in this role, please feel free to reach out to me for the US-based role and reach out to Sai, my colleagues, for the UK role. Thank you.